Hi, everybody. Welcome to Speakeasy JS, the meetup for mad science, hacking, and experiments. I'm Faraz, and I'll be your host this afternoon. Mad science is about building things that make people say, I didn't know that was possible. So today, we're joined by Rasmus Porsager, joining us from Copenhagen. Hi, Rasmus. How's it going?
Hi. Good. How about you?
Pretty good. Really glad to have you here.
Thanks. Glad to be here.
So it's 1 a.m. in Copenhagen, so we're really grateful for you staying awake to join us now. I feel like this time is just so hard for everybody in Europe, but we're really grateful that you're joining us.
Oh, it's good.
Nice. So Rasmus is the maintainer of, I guess, author and maintainer of Postgres JS, which is a super fast Postgres client for Node.js. And it's a very small number of lines of code and has 0 dependencies. Is that right?
Yeah.
Yeah, so pretty cool project. And Rasmus has also dabbled in quite a few other interesting projects, but he was telling me how he doesn't usually have time to tell people about them. So that's why actually I'm really excited that he's taking the time today to share HashQL with us, which is the topic for today.
Right.
Cool. So with that, yeah, you can take it away, Rasmus. The stage is yours.
Cool. Yeah. So you copied the fine title from the repo that doesn't contain anything but the quote about Chuck Norris. I'm sorry about that, but HashQL is taking the old idea of writing your backend code in the client, which usually is something like SQL, which is a big no-no. You don't want SQL injection, you don't want remote code execution, but HashQL kind of goes around all that by simply taking your query when you write it in your client code, and then at build time, it replaces it with its hash, and then you load that table of hashes and queries into the server, and then you only pass the hash and the input over the wire. So it's basically as safe as anything else, if not at times probably safer, because you can only call a certain request in a specific way. So it's a bit like HashQL, but without all the plumbing. So I think it was about 3 years ago, I started getting into Postgres, and I quickly got tired of writing the same plumbing over and over again. So that's when I came up with the idea of just writing it all in my client code. And I shared a proof of concept with the Mithril community. Mithril is a Vue library like React, but it has a really great small community. And it turned out James Forbes, another guy there who taught me a lot of Postgres, he had the same ideas. So I think that's when we kind of figured out we were onto something. So we got this small thing up and going, and I think, yeah, we just got busy with work and stuff. And luckily, I was able to use this at my work. So we've been running with this setup in production for over a year now. So even though I'd say it's kind of mad science, it's working somewhere at least. So I think I'm just going to jump right into an example, take you through it so you can see what the general idea is. HashQL, this implementation, because the implementation is not that big, but it consists of 3 parts. So you have a client, which you use in your client-side JavaScript. And then there's a build plugin. Currently, it's just Rollup, but it shouldn't be hard to make for anything else. And then there's the server module. So in this example, I do have a few other things that I hope you can see past, but the Vue library I'm using is another project I haven't finished and released, but HashQL is here. So this is your basic front-end code. that could start like this. And to get started, you'll simply just call the HashQL function, and then you decide what kind of backends do you want to talk to. And HashQL will produce 2 tag template functions for you that comes from this array. And the only thing you have to do is decide how do you want to transport that to the server. So you can use HTTP, WebSockets, basically anything. In this case, s.request is kind of like fetch. There wouldn't be any issue in replacing this with fetch and then using that to transport the request to the server. So HashQL takes care of supplying your implementation with the correct object. Now this object contains the hash and the input, and I'll show you what that is. So HashQL for JavaScript relies heavily on template strings. So in this small to-do sample, you can actually get started just by doing this. And normally you would either have a REST API where you would query /todos, or you would have GraphQL where you would have a server in between that does all the plumbing for you, and you could get, a pretty correct result back from the server with GraphQL. With HashQL, you can do the same, but you don't need to do the plumbing on the backend because you're just, in this case, writing SQL. So here I could take the specific fields I'd like instead of selecting everything. Usually you just use star for development, but so we'll do that in this case. This view library is, I don't know if you've seen stuff that uses Hyperscript or React. Like this is basically just, this is the tag name, and you can write inline styling here, and then the tag template function returns a function that takes the children. So if you squint a little, it'll probably look like HTML. So, and CSS down here. There's shorthands for CSS properties. So this is that. Not related to HashQL, just so you kind of get an idea about what's happening.
Yeah, that's helpful.
Yeah, so we store the result of the SQL query in the to-dos array. And in this case, there aren't any yet. Normally in a real project, I probably wouldn't structure it like this, but the interesting thing here is that you can inline everything, and then you can abstract out once you feel that it's necessary. So the flow in development is just really cool because you're just making things as you go along where it makes sense, and then you can pull things out. So you never end up doing premature abstraction this way. Yeah, so I'm just gonna pull up and inspect here. So I have a shortcut for logging. So in this case, if I do P around it, I get the result in console log. So here is an empty array because we don't have any to-dos yet. This input just adds a new to-do. So if we go down and look at that, here is the unsubmit for this field and the submit button. And it simply does this. It just does to-dos that push, and then it awaits an SQL query that inserts a new to-do with the title from the input element and returns the object from the database. So I would do clean kitchen. And what's happening here is that HashQL sends a request over the network. We can see we have 2 requests. The first one is just for the, what do you call it, for the to-dos. And in this case, I'm in development mode. So it sends the complete query. There's no reason to replace it with hashes when we're developing. That means you don't need to bundle anything while developing. You can just add that as a build step in the end. But if I just quit this one and now I'm going to start in production mode. And we can go to inspect again. Oops. If we look at the request now, you get a hash here. So this is basically the only thing that is sent to the server, this small object. And the inputs are empty because in our query, we haven't used any arguments. But we could do where title equals, and then like this. So imagine we want to, let's put in some more to-dos. Okay, so imagine we want to filter this. Usually you would go to your backend, you would create a new implementation of some endpoint that would allow you to give a query or some string to filter your results by. In this case, we don't have to touch the backend. So we only have to restructure our code a little if we wanted to refresh live. You can see the static way. We could just do, let's find something that's in at least, yeah, just up. Oops. So, sorry, I'll just do that. So in this case, it's completely static. I could just as well have written it inside the tag template, but now it's an input to the request. So you can see it contains an array with the value of the argument. The reason this is wrapped in an object is because HashQL automatically takes any nested query and transfers the complete group of requests with their inputs to the server. And then the server executes them in the most optimal way. So you just have one request going to the server, even though you would do something crazy like having another SQL query in here. Let's say you would probably write this in SQL directly. But you could have, imagine you have two SQL servers and you need to grab the input from another one. You could just put it directly in here and there would only be a single request to the server. Let's try and make this dynamic real quick. Just so you can get a sense of what it'll do.
What is that object at the top there that you added filter to? Is that part of the
that's
templating
just
language?
me abusing the default values. So instead of writing filter, I just use it for the input arguments for this. So in this view framework, this is a component where these are the attributes you pass to the component.
Okay, got it.
So it's probably simpler just to have it like this. And then we can do fetch. And that's all good, but we don't have, let's see. Let's make an input for the filter. And I've got an issue somewhere. Just a second. Whoops.
No worries.
There we go. Okay. So now we have this, or do we?
This filter needs to be in the default argument list. Did I mess it up by making you make it a variable?
This should be fine. Fine. Sorry, of course.
No worries.
This isn't magic. I need to call fetch, of course.
Yeah, I'm not seeing anything. If you're watching the stream and you have an idea.
I think I just forgot to save, perhaps. Yeah.
Oh, nice. Okay, no worries.
Okay, perfect. So yeah, so in this case, we've implemented a filter function, which would usually take a huge amount of work, but it just works directly. And there's nothing dangerous in this request we're sending. It's simply a hash and a value. So that's basically how this works all the way down. And as I said, everything's inline. So if you click the checkbox, it's just going to go ahead, call the SQL, set done to the check value for the specific to-do item. So these are also stored in the database. Yeah, so that's basically the feeling on the front end when you're using HashQL. Just to show you, because it might be a bit interesting, this is the only client code for the front end. So you don't need to pull in a crazy huge library to start using HashQL either. The server end is also fairly simple, in my opinion. I've tried and made it as bare bones as possible. So there's no Express framework, no nothing. It's just a basic Node HTTP server. And you include HashQL like this. And then to make you can do, oh yeah, that's another thing I should mention. The queries that are created at build time, where you have the key is the hash, and then the actual query is the tagged template array. So for anyone who doesn't know tagged template functions, in JavaScript, when you use them, the function that handles them is gets the first argument is an array of every part of the string around the interpolated values that you put inside it. And the remaining arguments are the input values. So a tag template function can kind of do anything it wants before the string is put back together. So in this case, our queries JSON looks like, in this case, we just store the map in a JSON file on the server to keep it simple. So here is the hash for this string, which doesn't contain any inputs, but this one does. So here you have update to do, set done, and then here in between comes the value that you have from your front end. That's what is passed in the query as the input array here. So the server can put it back together once it gets the hash and the input for the request. The cool thing here is that you actually sidestep doing any kind of versioning. If you do it this way, of course, you have to be sure that clients are always up to date. But you could equally as well just put the hash and your query inside a database together with your build number, and then you would have support for multiple versions throughout your development cycle. And you wouldn't have to version anything. In the off case that you had some old request you don't want to support anymore, you could just remove them from the database, and the user would get an error depending on how you handle HashQL not found errors. So that's the first.
Yeah. I have a question. Would another option be just to continually append to that queries.json file, like never remove?
Exactly. Yeah, you could check it into JIT as well, and then just continually append to it. The reason I'm thinking the database is interesting too is because then you can keep statistics over how many times are each request logged, all these kinds of things. You could put rate limiting on some of them if you figure out, oh, this one is running loose, or yeah.
Neat. That's really cool.
So the first thing we do is just, if we're developing, we just say that our queries is whatever the client sent us, because then we don't need to do any build stuff while developing. But for production, we load the queries.json file, and then the HashQL module just here, it expects either an object or a function. So this one could also be a function that went and fetch query from database, or something like that. This looks like this. Whoops. So you can go ahead and do whatever you want on this side. And then it requires you to have handlers for each of the backends you've specified. So in our case, it was SQL and Node. And on the server, you need to have handlers for them as well. So I've moved them to some other files to keep it a bit clean. This function then takes the object that you sent from the client over HTTP or WebSockets or whatever, turns it into something that your handler function can use. And it also makes sure that if you have any nested queries, your handler functions won't know about that. They'll just get a single thing they have to respond to and give the result back. So if you have a big SQL query with, like, let's say you want to fetch stuff from GitHub and stuff from 3 other sites, then your Node backend will actually run those 4 subqueries in parallel, put them into the SQL function, and then the SQL function will run, and the result will be returned to the client. And yeah, I have in some of our work stuff, I have a really cool setup where I start out by creating, for uploading files, for instance, I create a file row in the database, I get ID back, or I put in the ID myself, then I upload the file to, I request a put object from S3, also in the client. So you kind of have the entire flow of the file upload in a single place, instead of constantly going to an endpoint, getting something back, and all this back and forth that you're used to. And then at the end, if the upload to S3 went successfully, it'll push the resulting checksum and info about the file to the database. So the server in this case is, it's very simple. It's just going to take the body that we're sending it and then return the result after your handler has done whatever it needs to do. So if we look at the SQL handler, in this case, I'm using my own library, Postgres. It's nothing more than this. So Postgres is I would call it a secure by default from SQL injection library. So it also uses template strings. And in this case, we kind of cheat a little. So HashQL wants a handler function that looks like a tag template function, which is the first here is an array containing the strings, and then the rest of the arguments are the inputs. Tag template strings have an array which has the raw cooked strings. You can probably go read more about that on MDN or somewhere, in a raw object. And that's what my Postgres library used to check that it's actually a tag template function calling it. So I can just go ahead and put that directly to that library, and it'll do the rest. Really quickly, Postgres will take a query that looks like this, for instance. Which doesn't make sense if you know SQL, but it would turn it into this SQL. And then it would pass the parameter. This is a really bad sample.
Yeah.
The Postgres protocol just expects integer-based parameters, and then PostgreSQL will make sure that there can be no SQL injection. So the WAT is passed to Postgres as an input. So this makes it completely safe from any kind of SQL injection. Okay. Then let's see, how far have I gone? Time passes by quickly. Okay. Yeah, so real quickly, just to show that my use case was SQL. That's where I started out with, but you can do anything. You can scrap all your Lambda functions, and you can just run the node functions directly in the client code as well if you'd like. So for instance, I think I have just a second. I'm going to save us some time here. I made a small sample where, let's say we wanted to check out the files. So here we have a node function through HashQL that simply just reads the files in a folder. Let's just try and put it at the top. Just a second.
Oh, oops. Wow, that's really cool. So the node tag template is completely arbitrary. It's not SQL at all.
Yeah, exactly. It's not specific to SQL. So in this case, I'm just going to read the files in the current folder. And this small module up here basically says, okay, we're going to take a folder as an input. We're going to have a variable for which file is selected in this folder. Then we're going to fetch the files like this. And this is just FS promises. Then we read the directory for this folder. And yeah, as you can see, none of this has proper error handling. So this is also just. Then we're going to map over the files, make a new list item. And if we click that, we set it as active. And then we're going to call the same module again. So some nice recursion. And that actually gives us a way to browse this, if I'm correct. Let's see. Files is not a function. I think I changed this at last. Just a second. Okay. So now we can just, yeah.
Wow, that's really cool.
Yeah, I thought that was a fun one to show because, of course, I don't know, you would probably, there's so many ways you can use this. And of course, this is only safe in the sense that this input is controlled by the user making the request, but none of the rest is reachable to them. So the node implementation in this case is a bit bigger than the SQL one, but it's basically just taking the inputs, stringifying them, and putting them into the script. If anyone can see any way to hack this, that's suggestions are more than welcome. because I'm using this in a few places.
Okay, yeah. I mean, that's the first thing that comes to my mind is this seems very high stakes to get right.
Yeah. Yeah. Perhaps.
Yeah. I'll take a look at it. It's open source under the HashQL repo,
Yeah.
right? I'll take a peek at it myself and see.
I hope I can. I have like a half README and some more documentation. I should probably be able to push that at some point. But again, the implementation of HashQL itself is very small. So the server is just this, and you could scrap this if you didn't want to have the parallel query stuff. What all this does is to say, if I have a query inside another query, we're going to run all the subqueries in parallel, return the outputs to the parent query, and then run that. So just to show a sample of that, real simple could be that, let's say we want to fetch, then, their environment that contains the host name. We could do so in this case, I haven't figured out how to do imports dynamically like this. I got an error from Node, so I'm just passing the required module. That's a bit of cheating, but okay. Let me just see here.
So I guess I'll wait till you finish task.
No, go ahead. We can skip this. I can show it later.
Yeah, it's super interesting. So there was a question in the chat that I thought was really good. Was why handle queries like that, juggle queries like this versus using crypto signing? So like if you had a way to sign the whole string, then you could just pass the client could just pass this, the signed query to the server, and the server could verify the signature and know that it's
right. And you would get rid of the build step, but you wouldn't get rid of the build step because you wouldn't want the client to be able to see the query either.
Oh,
so
I see.
The idea is also to prevent the client from seeing what is this query actually about, because you might expose a lot of internal specifics that could compromise your system. So I imagine the question is if, for instance, or which module you're using. If you use some module that has a 0-day thing, I don't know. But I'm getting the question right, that the idea is to sign the full request. Maybe I'm misunderstanding it.
Yeah, there's a clarification here from them. You'd still need to build to sign it, but you wouldn't need build step to be able to update info in the server, potentially avoiding a server restart or something when client updates. I see. So the server could take any signed query and just blindly run it and not need to have like a manifest.
Oh, but you could do that with the hash as well. There's nothing preventing you from having a live push to your server of the hashes. The reason the hashes were chosen, and in this case actually MD5, is because there isn't a chance of collision when you have queries like this. I mean, the collisions they found was PDF files they kind of mixed and matched until it worked out right. So, but you could totally replace that with any other hashing function if you'd like, and if you didn't feel secure using MD5. But
MD5
is also the shortest one for the request. So if you sign a completely complete query. I can just show you real quick I think I have a long one over here, but I think I have like a query of 100 lines SQL, and if I'm gonna, there's no reason to give that to the client to send in a. Maybe I don't.
No, I think you're understanding the question correctly.
Okay.
I think, yeah. That makes sense. Yeah, I think at least Tiny Fluff can clarify in the chat if we didn't understand their question correctly.
Yeah.
But that makes sense. I mean, you're basically trying to avoid exposing the query in the client, and you're also trying to make the bundle size smaller.
Right. The only way to make these requests smaller would be having / like just having them convert them to integers instead, right? I mean, but you're never going to get a request larger than the actual inputs and the 32 characters in the MD5 checksum.
Mm-hmm. Yeah, I actually haven't used MD5 in so long, but I would be afraid to be using. I would use like what TinyFluff's actually suggesting in the chat, to use a longer hashing algorithm and then slice it just to the size you want, because I actually don't know what the exact attacks on MD5 were, but I am a little scared of it. I still use SHA-1 myself in a few places because it's used in the BitTorrent protocol, and I use that for a few things.
The thing is that how should, with MD5, it's you could skip MD5 and you can just use a random ID. But the cool thing about MD5 is that you get
I see what you're
duplication. It doesn't matter at all, because you're the one generating them. So there's not really a security issue there.
Yeah, it would only matter if you were sending along like the query and then the server only stored the hashes, and then you could provide a bad query that hashed to the same thing, but that's not how it's designed. You designed it so that the server has the query and then the MD5 hash is the ID. You're totally right. Yeah. False alarm.
Okay.
Yeah.
No, yeah, but that's good. I mean, it's definitely so. I want the alarms to be on for.
Yeah, I'm just trying to think, because I mean,
so.
SQL in the client is, you're just tempting all the people who take security seriously to take a really good look at this. You're just like they're salivating, thinking about all the ways maybe they could do something. But I think so far it sounds I can't see any obvious. I can't see any obvious problems. So are you thinking about this as an alternative to GraphQL because of the simplicity of, like, because then that's one of the main things that GraphQL is supposed to be helpful for, is that like a front end developer could decide to fetch these 3 pieces of data instead of the whole table, or then now they could add a 4th one or a 5th one. They could quickly change it, and they don't have to go and modify like a backend API route or add a new route and that kind of thing. And so that seems like this has a lot of the same benefits.
It has, and there's of course the other thing that you would have to structure if you're a big team or a big company and you have separate roles for front end and back end. You would figure out how to structure it around this, because with GraphQL there's still some back-end engineer who gets to decide what's going on, but you could do the same with this. I mean, you could just have it in your review process, and the developers could get on with their life doing what they're supposed to.
Right. And you don't have to learn a new language too, which is nice. You can keep
exactly.
Using, a lot of people. I mean, a lot of the benefits of GraphQL sounds like you can get them without having to switch away from SQL if that's what you're more comfortable with, which is pretty cool. Yeah,
I think that was part of the thing that pushed me to it. I didn't want to learn GraphQL, so.
Yeah, I've yet to look at that or need it. I'm sure it's really helpful for large team situations or really complicated apps. But I've always had just a handful of API routes and the things I've designed so far. So it's like, okay, I'll just go to that one API file and make a change. It's not that hard.
Right.
So I haven't really learned it much either. So Okay, so that's cool. So yeah, my main questions were the security ones. I'm glad we got those off the table. Did you have anything else you're showing, by the way? I feel like we interrupted you with these questions. Did you want to finish showing that thing, or what do you want to do?
No, that didn't matter much. It was just the part about the parallel queries getting run as a single request to the server, but explaining it should be fine. So that just works as well. But there was one thing I thought, yeah, so when we're using this in production, we're actually, we have a multi-tenant setup. So we use row-level security in Postgres, which means that any user that logs in opens a WebSocket and gets assigned its role, user ID, and tenant ID. And then any request that is made to the database through HashQL is put in a transaction that that embeds their role, user ID, and tenant ID. So instead of, when you're designing a site, having to go remember user ID equals currently logged in user, whatever, that's just that just happens automatically. And I think I can actually show it without course. Yeah, so just have to make this. In this case, here, this is how you start a transaction with the Postgres library. This is just cheating it like before. And here we go and call this function first. So I have a Postgres function called auth_as, and it's going to put in the user ID and the account ID and the session ID of the current user. And then it's going to run the query. So that means anything that's scoped to this user through row-level security policies will be the only thing returned. And it'll also mean that if the user's role isn't allowed to update a row or delete a row, it'll also be stopped here. So it's a really small way of enforcing user rights. And you got it all the way at the database. So I imagine you could even expose a HashQL API, and you could allow someone to build with HashQL and then push their queries to your server, and you could go through them and ensure that they were good, and then let them use it just as they would use a GraphQL API or REST API or whatever.
I see. So then, if you did that, would you need to do the like if you had? I haven't used this this row level Postgres security before, but does that mean that you can just like let the client write whatever query they want and there's really nothing they can?
Yeah, if you've made your security setup and made your row level security policies correct, then yeah, that wouldn't be.
That's amazing. Okay.
Yeah, that's
neat. Yeah. So this has been running in production, you said, for like around a year. Is that right?
Right.
Have you run into any like major issues with it, or things that like downsides that you didn't expect, or any, I guess, really positive things that you didn't expect?
I think a really positive thing is that if I have a query that doesn't work as I want it to, I can just rewrite it as I want to, and I don't need to keep API versions or things aligned. So it's been really seamless. But I think I started out just having the JSON file generated, but then I moved the queries to the database, and they're kept in memory on the server, of course. But yeah. I can't think of any negatives yet I've bumped into, honestly.
It's a little suspicious, but
yeah. I think so. It's mostly me working on this project. So one thing is that if I don't kind of have a little discipline, it can get a bit messy if you don't remember to abstract things once you land on the final implementation. But on the other hand, it's more to kind of, when you come back to read at it, it's there in one place. So I'm not even sure yet. I haven't decided if I would want to abstract out and put the queries in their own files and stuff like that. But one thing some people I think would find very annoying is the fact that it's tag template strings. I like the fact that it's just all green. I don't need the color highlighting, but you could get that for editors. I know that Sublime and Visual Code both have support for highlighting SQL and CSS and all these tag template setups. But James Forbes, the guy that I've been working on it with, he has this idea about actually being able to pull out the queries and then type them as well. But yeah, that's another story. But there's an issue on the HashQL repo where he explains it. That's interesting as well for people who like TypeScript and yeah, things like that.
Cool. So I'll put the link up on the screen so people can check out the repo. As you mentioned, there's not really...
apologies for the missing README. There's not much there, but
yeah. But it's a really cool project.
To do sample up as well afterwards with a little more extensive README. Cool.
Well, yeah, I think that's all the time we have for the talk. But thank you so much for presenting all that to us. It's super interesting. I'm looking forward to looking at the node thing you showed and seeing if there's if I can find any security bugs, just because that sounds exciting to look for. But it's also a super cool way of writing applications. I want to give it a try, but I'm a little hesitant because the no docs. But I'm not that afraid. I'll dig into it. I'll dig into it anyway. And that's the kind of stuff, like I said, we show on Speakeasy is the stuff that's like really bleeding edge. Just a couple weeks ago, we had Fred Schott showing us a web framework that he made, which is like not even, you can't even try it or even install it yet. It's completely just on his own computer. So there's very different levels of polish. So this is very much further along than that. So and it's a really cool idea. So thanks for sharing it with us.